Okay, guys, so let's continue our discussion on word combinations. This time we try to focus more on LRFD. So, as soon as the LRFD load combinations has been introduced in steel design, the American Concrete Institute thought of phasing out the strength reduction factor plus the load combinations in the concrete design. So what happened is they want both steel design and uh, concrete design perhaps use the same load combinations, but they want to make some uh, gradual change in the use of it, since we basically know that steel structures behave differently, and we have to consider a lot of things when we talk of ductility and serviceability. Perhaps in this premise, they wanted to make a shift from strength design approach to LRP approach with the version. Okay, so for ACI 2002, which is the start of the LRFD load combinations in concrete, we basically just copied all the ACI, rather, copied all the load combinations that was used in students, but made use of some notations here and uh, perhaps explain to us how these notes will help us understand better the use of the factors, and if certain adjustments are needed, we can immediately do it, no, on our distribution. So take note that here in note letter A, the uh, factor F1, which is normally written beside the live load, right? It has a value either equivalent to only two values, no? So this could only be equivalent to 0.5 or 1.0, depending upon the value of the live load itself. Okay? So it only perhaps gives us an idea that if the weight of the occupant is greater than 100 pounds per square foot, which is normally existent on public assembly, garages, and storages, no? We can actually reduce that live load by 50%, okay, or to 50%. So that's 0.5. But if it is smaller than 100 PSF, or the occupancy is not for garages and public assembly, or maybe storages, then the live load can cannot be reduced to 50%. Okay, so this is 0.5 mm. So this is the first note. So for the second note, where the wind load has not yet been reduced by a directionality factor, it should be permitted to use 1.3 W in place of 1.6 W. Okay, so because wind analysis is perhaps done using a lot of methods. Now we have the directionality procedure, we have the envelope procedure, we also have the wind tunnel procedure. So sometimes the factor for directionality, which is KT, is often ignored, no, in several locations, and in that case, we can replace, no, this 1.6 directly into a 1.3 W in that regard. Okay, so KD is not applicable, but take note that if you already use KD, you have to use 1.6 W uh, to make uh, your calculation perhaps more compliant with the code requirement given to us by the ACI. Okay, so normally this is KD is 0.85 to 1.0 depending upon the nature of your loads. Okay, for letter C, where the earthquake load is based on service load level system forces, again, this is the term used here. So what's the meaning of this is a big question. How do you know that your earthquake is made or computed in terms of the service level system forces? But if you know how to distinguish that from the other, then we can simply settle what to use if we will consider 1.40 or 1.0. Okay, and for the load number 3, the load factor at H shall be set equal to 0 if the structural action due to H counteracts the due to W or E, or where the lateral earth pressure provides resistance to structural action from the forces should not be included in H but should be included in the design system. So this has something to do with your earth pressure. If your earth pressure is active, passive, or at rest. Okay, so we have to have a good uh, idea on what these terms are in order for us to apply an analysis, whether to neglect or to consider lateral earth pressure each. So for letter E, if the resistance of the impact effects is taken into account in design, such effects should be included with that likely. So we just change L to L plus B. Okay, so this includes the vehicular loads. And for letter F, estimate of the effects above should be based on a realistic assessment of such effects occurring at service levels. Okay, so that's basically an LRFD scenario, an LRFD on concrete design. So for the NSCP 101-01 LRFD, you will notice that they are very much similar. Only some load or load effects here were not treated, but they are still considered. They may be considered. So 1.4D, 1.2, 1.6.5, okay, 1.2, 1.6, and 1.8 are there. So they are basically the same. 1.2, 1.3, F 1.5, 1.2, 1.0. So basically they are the same, except for some uh, okay, so this 1.6W here is missing here. Okay, so 1.6 is not here because again we are considering here directionality already applied. Okay, so if KD is already applied, okay, but basically these are just what to say, okay, 1.9, 1.3. So F1, 0.5, 1 and zero point 0.5. So these are the things that I discussed here a while ago. And also, Doji, where F, H, P, or T are together, each applicable load should be added with the above combination factor as follows: 1.3 F, 1.6 H, 1.2 P, 1.2 P. So note that this 1.3 F, the fluid pressure, okay, has something to do with basically with the wind. Also, your 1.6 has something to do with the wind. Your 1.2 P and 1.2 has something to do with the dead loads. Okay, because of the factors, you can see that the nature of their weight as far as the load factors are concerned are the same with that basically of the other significant or primary load cases like the wind and the dead loads. For the basic load combination in WST, because in NSCP some are still using WST at the year 2001, so this is still year 2001. We have this load combination basically as the basic load combination for AST. So the factors here are not load factors, but they are factors which are empirical to the equation itself. Okay, so here we're 1.4, W 1.4. So this 1.4 here are reduction factors, not based on probability, but they're based on experts' judgment. Okay, this 0.75 here is not has nothing to do with the increase, no, not 1.33 increase. So this has nothing to do with this 1.33 increase in allowable stress. Okay, and no increase in the allowable stress shall be used with the above load company except as specified and prohibited of 203.4.2. So for the alternate basic load combinations, so dito, a 1/3 increase now may be used. Okay, so basically we can use this if okay, we are considering dead, live, wind, or earthquake in this regard. So these are alternate load combinations wherein the 1.33 increase in allowable stress is considered. Okay, so for special seismic load combination, this can be done using both ASD and LRMT. Okay, Okay, so basically this is also an LRFD method. Special in the sense that it has to refer with the special provisions of the NSCP. Okay, I will be discussing to you this later. Okay, so EM here is the maximum earthquake permitted, okay, wherein some reliability, okay, or redundancy factors will have to be considered. Okay, but basically this is an LRFD, but it can be used both on AST and LRFD. For the ACI, so we are now on concrete design. So in the year 2001, okay, in the year 2001, the the NSCP have two combinations, both combinations used in steel design and in concrete design. Okay, that's why here, this is now the strength design for concrete. Okay, so this is now the allowable, the load combinations made. Basically, this is an old 1999 version of the ACI. Okay, wherein this is 1.4, 1.7, and then we have here this, and you get a 0.75 increase in allowable stress. Okay, so this is 1.33 increase in allowable stress. That's why you get a factor out of this. And then here, what happened is if I multiply 0.75 with this, I will get basically 1.32, I think. Okay, so I will be uh, explaining to you this in a different video. This will be derived to you in a separate video because I have to explain to you the effect of reliability factor in this. Okay, so reliability index raw will be applied to get this, and also this one here I think is included, and the rest are just the same. Okay, so this from fluid pressure up, or earth pressure, fluid pressure are just the same as that with the previous edition. So that's it for now on the NSCP comparisons of the load combinations. I'll explain to you further some of the important notes here that I have not explained on my next video. Thank you very much for listening. Have a nice day.